Hopefully you remember what velocity is on a position versus time graph or displacement versus time. They both mean the same thing. So we come over here and try to find the slope. So in order to do that, we do our run of 4 seconds. We rise 8 meters, rise over run, and we get 2 meters per second because 8 divided by 4 is 2. That is for the first 4 seconds. The next 4 we can look at and see that there is no rise at all. So if there is no rise and it is a flat line, then our slope will automatically be 0 meters per second. Okay, now let's move on to the little bit more in-depth analysis of the relationship between position versus time and velocity versus time. So we come over here, and I want to draw each of these position versus time graphs as a velocity versus time. So right here, we're able to see that this is a fast, steady pace because it is one just consistent straight line, right? So if I were to come over here, I would draw, I'm not actually going to do the math for it, I just want to kind of draw it. I'm going to draw a steady line that is going flat because there is no change in velocity. I just find a constant value and I'm showing that it is a little bit faster, right? Now, I want to look at this red one right here. This red one has a slower speed for the first 3 seconds. We'll say it's 3 seconds if we don't know, right? So it is at a lower point than the original one because the slope is less. Then it goes into a stationary thing, so all of a sudden it comes down here, and we're at 0 for about 3 seconds, 4 seconds. And because it's stationary, we know the slope is 0, so the velocity is 0. That's why we draw it like this. Then all of a sudden, it goes in a negative direction. Not exactly the same velocity, but just about. So if it is in the negative direction, we have to come over here and draw it down here. We want to define positive versus negative. Anytime you are going away from the origin is 0, the line at 0. Anytime you're moving away from it, we are going to say we are in a positive velocity. You can kind of even see that right here. These two were positive because they're moving away. Then it became stationary. It's kind of obvious that that is consistent. And then when we are moving towards the origin, so back towards this line, the x-axis, we were negative. This would be really important to write down so that you know. You can always double check yourself by doing the math. But if you are moving away from the origin, you're going in a positive direction. If you're moving towards the origin, you're going in a negative direction. Last one is something brand new. So what we have here is something that isn't a constant slope. In fact, it's getting faster. When it's getting faster, we know the velocity will be increasing over time. So what this will actually look like is it will look something like this, right? It'll look like any sort of line that is going in a positive direction that is constantly increasing. We can actually see this by taking something called the tangential velocity. You don't really need to know how to calculate this, but the basic premise of this is that anything that's on a circle or curved plane, you can look at any one point and draw a straight line from it. So I took the one at 0, and if I were to draw a straight line, it would look something like this. It's a steady slope that's kind of slow, but if I were to take a line up here and draw a straight line, you'll notice that the slope is much greater. You see how much quicker that one rises? That's the basic premise of how we know this is getting faster. And that's what it will look like on a VT graph.